Hello and welcome back. This is Mr. Laudermilk again from me, Junior High. Going over this is actually lesson 1.5. In this lesson, we're going to be solving equations by clearing decimals and fractions. It's a little trick that we'll do. You'll find it to be very beneficial when you have fractions, specifically when you're trying to distribute fractions or if you're trying to deal with fractions with multiple different denominators. This is definitely a skill that will save you a lot of time. I know that fractions can be troublesome, they can be time consuming, but this is going to be a nice trick to use that's going to be very beneficial for you. So in our warm up, which hopefully you've already done before you're watching this video, if not, pause the video right now and try it. In the warm up, what you're trying to do is figure out how can you clear these fractions? How can you get rid of them? So in question one, it says, I guess they're all question one, but the first one says, can I multiply 3/4? What can I multiply 3/4 by to get an answer of 3? Well, if I took 3/4 and multiplied it by 4, let's see here, 3/4, and I multiply by 4, think of 4 as 4 over 1, you'll notice that the 4's would cancel out, leaving me 3 over 1. So what would I multiply to get an answer of 3? I could multiply by 4. Which you'll notice is actually the denominator of the fraction. So if you multiply by the denominator of the fraction, the denominator goes away and you're just left with the numerator. It cancels out. Next question says, what can I multiply 5/7 by to get an answer of 5? Well, going along those same lines, if I multiplied by the denominator, the numerator would be left. So the answer here is I would multiply by 7, which is the denominator. What could I multiply 0.23 or 23 hundredths to get an answer of 23? Well, what you're trying to do there is move the decimal place 2 places to the right. And if you know anything about decimals, you're just multiplying by factors of 10, or I'm sorry, not factors of 10, multiples of 10 to get to, an answer of 23. So to move it 2 decimal places, I have to multiply by 10 twice, which would be like multiplying by 100. Another trick that I usually tell my students is however many decimal places you have to move, that's how many zeros should be in your multiple of 10. So that's where the 100 comes from. If you look at the next one, how could I multiply 0.5 to get an answer of 5? I would multiply by just 10 to get an answer of 5 because I have to move it 1 decimal place. And that's the warm-up. Now we're going to jump into the shared lesson. The shared lesson starts here. You'll notice that there are some steps along the side to help you as you're working through it if you want to look back. Again, the video is here to help you. If you want to try questions on your own, by all means you can, but we do want everyone to watch the videos because even if you're trying it on your own, we want to make sure that you have a way of checking your work. The videos is a good way to check your work. All right, make sure you do every example. So the first example, it says, multiply each term by a power of 10 to clear the decimal. So what you need to look at first is how many decimal places does it go to? This one goes to the 10th, this one goes to the 10th, so I could multiply by 10 to clear the decimal. So if I distribute the 10, I get 10y plus 105 equals negative 94. And again, all I did was multiply each by 10. So 10 times y is 10y, 10 times 10.5 is 105, 10 times negative 9.4 is negative 94. Just moving decimal places. Now again, if I follow along with those steps that I had alluded to a couple lessons back, DCGAM, nice little checklist. I've distributed, so that's done. Do not have to combine like terms, which is nice. So I can cross that out. Don't have to get the variable on one side. That's already done. So now I just have to add or subtract my constant and then multiply or divide by my coefficient. So I'm going to subtract 105 from both sides. Okay, so I get 10y equals negative 94 minus 105. They're the same sign, so I'm going to add them together and keep the sign. So I get negative 199. And again, this is easier. I'm dealing with whole numbers, integers, so I don't really have to deal with the decimals until the very end. Now I'm going to divide by 10. Dividing by 10 is just as easy as multiplying by 10. So when I divide by 10, that just tells me I have to move the decimal place one place to the left. So instead of negative 199, I'm going to get negative 19.9. And that would be my final answer. I could plug it back in and check. I'm going to tell you guys right now that it works and it's right. So if I were to plug negative 19.9 in, I would get the correct answer. Negative 19.9 plus 10.5 equals negative 9.4. Moving on to example 2 on this page. Again, I look to see how far do the decimal places go. In this example, they go to the hundredths place, so I need to multiply by 100. Put my checklist off to the side. I'm going to use a different color just so it doesn't get confusing. D, C, G, A, M. All right, go back to red to solve. So I have to distribute the 100. I put that in, so I'm going to distribute it. Some may ask, how is it possible that you're able to multiply an entire equation by 100, and at the end, you don't have to go back through and divide by the 100? Well, the answer there is it's because it's an equation. If this was an expression, I would not be able to do it. But because it's an equation, as long as I do everything to both sides of the equation, rules of equality, it all balances out. So it doesn't, once you do it, you're done. You don't have to worry about it at the end. So I'm going to multiply everything by 100. So negative 19.47 times 100 is negative 1,947. And again, if you were to multiply by a number and you're still left with the decimal, that means you did not use a big enough multiple of 10. You got to go bigger. Equals b times 100 is 100b. And then 4.67 times 100 is negative 467. All right. Now, I've distributed. Again, I don't have to combine like terms. I don't have to get the variable on one side. They're all on one side. I'm going to add or subtract my constant. So I'm going to add 467 to both sides. So these are different signs. So I'm actually going to do 1947. Let me take out my calculator. I do 1947 minus 467, and I get 1480. So I get negative 1,480 equals 100b. Trying to make my b not look like a 6, but it's 100b. Again, when I divided by 10 in the previous problem, I said it's relatively easy to divide by multiples of 10. When I divide by 100, I just need to move my decimal place twice now. So I get negative 14.8 equals b. I forgot to write in what step I did there, but I divided by 100 on both sides. And I get my final answer of negative 14.8. And the nice thing about clearing the fraction, or clearing the decimal, was once I got rid of it in the beginning, it didn't show up again until the end. So I could just deal with integers until the very end, and I divided by a nice 100, so it was nice and easy. We're going to move on to fractions now. So what do I do with fractions? Very similar to what we did with decimals. The only difference is they're not going to be always multiples of 10 that we're going to use to clear. We're going to look at our denominators and find our lowest common multiple of the denominator, also known as our common denominator. In this case, there's only one denominator, so it's very simple to decide what I need to multiply by. I'm going to multiply by 2. It's the only denominator we have. So when I multiply by 2, it's important to realize that when I do this, I'm distributing it to everything. A big mistake that I see within my students is they just distribute to the ones that have fractions and forget about the ones that don't have fractions, the integers. You got to multiply everything. Again, those rules of equality still exist here. So again, I'll put my checklist, D, C, G, A, M. I'm going to distribute the 2. So I'm going to get P divided by 2 times 2 is actually P. And the denominator just clears. Plus 6 equals 22. And where did the 6 and the 22 come from? I had to distribute the 2 to all 3 items inside the parentheses. Now I'm actually done with that step, done with that step, done with that step. I only have one last step to go, and then I'm done with this problem. That's how quick it can be when you're able to clear the denominator. So I subtract 6 from both sides, and I get P equals 16. And that's my final answer. I could easily check that. 16 divided by 2 is 8. 8 plus 3 is 11. Now, a lot of you guys, I know this is an accelerated class, and I get it. We can do a lot of math in our head. You probably could have looked at that problem initially and said, I already know it's 16. Mr. Lauerbuck, why in the world would I have to go through all the steps to multiply by 2 and then solve it out when I know right away it's 16? Well, yeah, maybe this one, it's relatively easy. You could do it in your head. But I guarantee you, we're going to get to ones, even within this lesson, that are not going to be able to be done in your head. And that's why we emphasize showing the work. That's why we emphasize doing these steps. This is going to save you so much time in the long run. Clearing fractions is a wonderful skill. So let's move on to another one where we get to clear a fraction. Again, I identify my denominator. So I look at this. It's 2z over 3 minus 7 equals negative 9. Again, I only have one denominator, so that's nice. That keeps my world simple. I know what I have to multiply by. I multiply by 3 because that's the only denominator I have. I'm going to put my checklist off to the side. D, C, G, A, M. Distribute the 3. I'm going to distribute that 3. Reminder, common error is people only want to distribute to the fraction. I'm going to distribute to everything. That's what keeps it following the rules of algebra. So I'm going to multiply everything by 3. So 2z over 3 times 3. Easy peasy, just the denominator goes away. I'm left with 2z. Put a little dash for my z's to make them different from my 2's. So you know, 7 times 3 is 21, so minus 21. Negative 9 times 3 is negative 27, so equals negative 27. All right, that step is done. Don't have to combine anything. Don't have to get the variable on one side. I do have to do these final 2 steps. So I'm going to add 21 to both sides. Add 21 to both sides. So I get 2z equals negative 6. Cross that step off, and now my last step is to get the variable completely isolated. So I'm going to divide by the 2, and I get z. Terrible looking z, but just deal with it. That's z equals negative 3. So I plug that back in to check it. 2 times negative 3 is negative 6. Negative 6 divided by 3 is negative 2. Negative 2 minus 7 is negative 9. Circle it, put a check mark next to it, whatever you got to do, confirming that that is correct. All right, we're going to move on to the last problem of the day. This last problem, we have that 1/4 there. This is where I always tell my students, don't turn into robots. We've been talking about clearing fractions over and over again, saying how you want to clear them in the first step. Now, always ask yourself, in every equation, does it make sense to clear the fraction? In this case, you could look at it and say, yeah, there's a 1/4 there. I want to get rid of it. So I can multiply everything by 4. And you wouldn't be wrong. You could do that. However, if you look, if I were to distribute the 1/4, remember distributing 1/4 is the same thing as dividing by 4. Both of these numbers, 16 and 60, are divisible by 4. So if I were to put in the step of multiplying by 4 and clearing it, it would actually add work. So I don't want to make my life more difficult. If I just distribute the 1/4, I'm not left with any fractions. So it really doesn't make sense in this case to clear it, because after the first step anyways, the fractions are gone. So when I'm doing this, I always want to ask myself, does clearing the fraction make it simpler? And the question you really just have to ask, will there be fractions left in my second step? If there are still fractions left in your second step, clear them every time. But in this case, 16 divided by 4 is 4, so I get 4x. 60 divided by 4 is 15. Look at this, second step, fractions are gone. So I didn't really need to clear fractions here. Again, I love this example because it teaches us, don't turn into a robot. Make sure that we're thinking like good problem solvers, like we all are. And we want to make sure that what we're doing is actually making an efficient choice in solving this problem. So for this problem, the efficient choice was just to distribute the 1/4. Now, when would I not want to distribute the 1/4? What if instead of 60, this was 55? Then if I took 1/4 of 55, I'm left with a fraction in the second step. I would want to clear the 1/4 right away. Again, ask yourself, is there going to be fractions in the second step? If there aren't, you don't need to clear them. If there are, get rid of them right away. All right, let's continue this problem. So I distributed. I don't need to combine like terms. I do need to get the variable on one side. I talked about it before. We want to find the smaller variable. So we're going to pick on the little variable here. We're going to take away 4x from both sides. Take away 4x. And I get 5x minus 5 equals 15. Then I'm going to add 5 to both sides. Oh, let me cross off that step. Add 5 to both sides. I get 5x equals 20. Divide by 5 on both sides. And I get x equals 4. Boom. Okay, plug it back in to confirm that it works. I'm going to tell you right now that it does. So that would be my final answer for that. So to wrap up the lesson, stay organized with your work. That's why I continue to do these steps. That's why I continue to put the things on the left side. That's why I do all of those things. Make sure that you know that each term is broken up by addition or subtraction symbol. So every term, if we're clearing something, you got to make sure that you distribute it to every single term. Okay, and then that's pretty much the example. And make sure that when you're distributing and when you're clearing, you got to make sure that you clear all of the fractions if there are still fractions left in the second step.